Hey everybody, this is chapter 3, section 1. We're going to look at inequalities, and we're going to do a lot of graphing for this particular section and kind of for the chapter too. So usually we're using a number line, which I think most of us have used ever since we were little kids. So hopefully we're okay with that, all right? So if we can go ahead and we can put in this first heading right here, a solution of an inequality. I just want to remind you too, as I'm doing these videos, I kind of go a little bit faster than I normally do. So please, feel like you're falling behind and taking notes, hit pause, get kind of caught up, and then hit play again and keep going, all right? And then always too, if you're not really sure about something, make sure you get a hold of me as soon as you can so that we can get things kind of straightened out, all right? So the definition for solution of inequality is any number that makes the inequality true. But with inequalities, we're going to learn that you can get multiple solutions. Okay. We'll kind of look at that compared to what we've been doing in the first two chapters that we've been working on before that. Let me fix this a little bit. All right. So what we're going to do here is I'm just going to uncover, there's some stuff here where I uncovered. Okay. So we're going to talk about inequalities, and the symbol here is the type of inequality symbol that we're going to get. We kind of get a different variations, okay? So if you could write down less than and then the symbol, and if you could draw this number line graph. And when I draw number lines, I just draw a line and I always put 0 on it. And that's really all I really do if I'm just kind of sketching it. So don't try to make a super elaborate one, okay? But we're going to graph some stuff here so we understand how to do it properly, okay? I'm going to use the variable x, okay? And I'm going to say, excuse me, that x is less than some number, and I'm just going to use 0. Pretty easy one to work with, okay? So to be able to graph this, I have to go find the value 0. But I have to indicate that that's a value that I'm going to use. On this one, I'm going to use an open circle. So I want you to write that down. Open circle on the value what you have, whatever that might be. You know, I pick 0, but it could be anything. Now, what I'm going to do is, like I said earlier, when we're solving these things or have to graph it, there's more than one answer. If I look, x represents all numbers, okay? But in this case, x has to be less than 0. Well, there's still lots of numbers that are less than 0. So which one are you talking about? Well, I'm going to indicate that by drawing a line from the value I had, which was 0, and show that line represents all the different values I can get. Well, that could be all the negative numbers. Well, there's, you know, basically infinite number of negative numbers. So -2 is less than 0. -10 is less than 0. -100 is less than 0, and so on and so on and so on, okay? So I need to indicate that using my graph. I put an open circle on 0 to say that you can't have 0 be a solution. Because if you stick 0 in for x, is 0 less than 0? Well, it's not. It's equal to. Okay, so we got to make sure that we're kind of being really specific on what values will work. Okay, the next one, if you could write down, is greater than, and this is the symbol for it. Okay, go ahead and draw another number line for that. I'm going to use x again, and I'm going to use 0 again. Okay, so once again, I go to the value that I have 0, because it's this case greater than, I'm still going to use an open circle. But in this case, I'm looking at numbers that are bigger than 0. So that means I go in this direction. Okay, so all the numbers in that direction will make the inequality true. So x is 2. Is 2 greater than 0? Yes. X is 10. Is 10 greater than 0? Yes. And so on down the line. Okay. So open circles just say I can't use that number, but I'm going to start from there. And anything in one particular direction is going to work. Now I just want to tip you off here. You know, you look at this symbol, it's pointing to the left. Well, which way did my arrow go? It went left. The second one, my arrow's pointing to the right. Well, which way did it go on my number line? It went to the right. So the symbol actually helps you with drawing your graph. It tells you which way to draw it. Okay? All right, so here we go. We're going to change things up just a little bit. We're going to have less than or equal to. And the symbol is going to be this. Okay, so really what the symbol is changing, because what I'm doing is I'm putting like a half of an equal sign underneath it. So that means a number that is equal to something would also work as a solution to the inequality. So I'm going to take x, but I'm going to change things up a little bit. I'm going to put 2. All right. But now when I have that equal sign attached to the inequality, I'm going to have a closed circle. Okay, so I find the value again. In this case, it's 2. And I'm going to put a closed circle there because I could have 2. Is 2 less than or equal to 2? Well, it is equal, so it will work. But then I also have to indicate that there's other solutions. So I'm using my arrow again. Or my symbol, I'm sorry, and I'm going to draw my arrow in that particular direction. It's pointing in the direction I should draw my line on the graph. Okay. All right, the last one is greater than or equal to. The symbol is that. And I'm just going to go and use x again. And 2. Once again, I've got this little equal sign with it. So I'm going to go to 2 and I'm going to put a closed circle. My arrow is pointing to the right, so I'm going to draw my arrow going right. Okay. So there you go. Taking the different inequality terms, associating them with the symbol, and then being able to graph it on a number line. Okay. If you guys could go ahead and write down these 3 headings. And we're going to go and be able to write an inequality based on what it says. Okay, so we're going to learn how to take the words and turn it into an expression. Okay. Over the numbers x means that I have a variable of x. Okay. And it's less than or equal to -7. So less than or equal to, so remember less than points to the left and the little equal thing underneath it, and my value is -7, okay? So, just taking what the words are, if you don't want to put it into an expression. I might also ask you to go ahead and graph it. So there's my graph. I find -7. I look at my symbol. It's also equal to, so that means closed circle. And it's less than, so my arrow is going to go to the left. Okay. Next one, m is less than 100, so m is now my variable. Less than, and my value is 100. Okay. Well, this one gets a little bit tricky. We got less than actually being said twice. This first part takes us back to chapter 1. Well, we had to just write that. Now, in chapter 1, we're just taking that and writing a statement. So 6 less than a number k actually tells me that 6 is something less than a number k. When we did that, that meant subtraction. Okay, so but it also told me to flip the order. So k less than 6 gives me that. And then I can go to this one. This one now is actually talking about our inequality. Okay, so less than 13. Okay, and then I might need to go ahead and solve that. So I might add 6 to both sides, and I can solve it for k. K is going to be less than 13, and I may need to go and graph that one. So 0, I find 13. It's less than, so open circle. Arrow goes in the direction of less than, so to the left. Okay. Okay. On these particular ones, I'm given 3 values, and what I need to do is plug them in for x one at a time and solve it and see if that value makes the statement true or false. Okay, so every math question is true or false. True, it means it works. False means it doesn't work. I proved something was incorrect. Okay, so I'm going to take this negative 3. I'm going to plug it in for x in the inequality that they give me, and I'm just going to do some math. Okay, so 2 times negative 3 is a negative 6, plus 1 is greater than negative 3. I'm going to put these two together on the left. I get negative 5 is greater than negative 3. True or false? Well, we always kind of use 0 as kind of my landmark. Whatever number's closest to 0 is the biggest when it's negative. Okay. Well, negative 3 is closer to 0 than negative 5. So negative 3 is actually greater than negative 5. So this is false. Okay. They give me a 5. I'm going to go ahead and plug that in. And I get this. I'm going to go ahead and do my math. And I get 11 is greater than negative 3. True or false? Well, pretty much any positive number is greater than the negative number. So that's true. Okay. Last one is a negative 1. So I'm going to go ahead and plug that in. 2 times negative 1 is negative 2. Negative 2 plus 1 is a negative 1. And is negative 1 greater than negative 3? And yes, it is, because negative 1 is closer to 0 than negative 3. So that's true. Okay. All right. In this particular question here, they're asking what's the relationship between what kind of a solution I get for 2x plus 1 equals negative 3, and what kind of solution I get for the same thing except with the inequality. Okay, just really quickly, if I solve this first one for x, I get x is equal to negative 2 if I do all my math. Okay, well, how many answers did I get? I got one solution, and that's it. Okay? If I go and solve this inequality, I'll get the same answer, but it's greater than negative 2. Well, how many answers am I going to get there? Well, I'm going to get like a lot, because it's any number that's greater than negative 2. So that's 0. That's 2, 10, 100, and so on. So I can get many solutions when I have an inequality. When I have just this is called a linear equation. When I have a linear equation, I get one answer. Okay? All right. So if you guys can go ahead and draw these 2 inequalities and the 2 number lines, please. Once again, 2, you could always just put 0 on the number line, and you don't really have to go and put all the numbers on it. Okay, and the second one, we like to have the variable on the left. So I could just flip this, but I have to flip everything. Okay, so back here the symbol was pointing towards X. I got to make sure it's still doing it, and I got +2. So on those, just flip them. Okay, so I'm going to go ahead and find in this one X is less than -3, so I'm going to find -3. It's just less than, so that reminds me, if I go back to my notes, that's an open circle, and the arrow or the symbol is actually pointing to the left, so I go left. Okay. On the second one, I find +2, and it's less than or equal to, so that kind of symbol tells me a solid point. And that one's pointing to the left, so I'm going to go left with my line. So I'm graphing the inequality. Right. So hopefully that's not too difficult. Just flip this. If the variable's on the right, flip it all around. Okay. Next set, if you guys copy these 3 number lines down, and then also the graph that goes with it. Then we're going to go ahead and write the inequality for this. Okay. I'm going to use X again. So I'm going to look at the value. It's -1. It's a solid point, so I know that it has to be equal to, and the arrow's actually pointing to the right, so my symbol has to point right, and it's going to be equal to, so I need to throw that on there, and I use the value that the graph starts at. Okay, so hopefully not too hard. All right, we're going to come to the second one. I find my value. It's at 4, but it's an open circle, so that means it can't be equal to it. And my arrow is going left, so I'm going to make my symbol go left. And I'm going to take the value that is on the number line. Okay. Once again, I'm going to take X. I'm going to find the value that it's at. Looks like it starts at -2. It's an open circle, so it can't be equal to, but it's going to the right, so my symbol needs to go right, or point to the right, and it's at -2. Okay? All right, so hopefully not too hard there, that one. Okay, you get kind of these word problems. These are just kind of pictures, though. But we need to write an inequality to describe the situation. And they want us to define a specific variable, okay? So in this first picture, it says trail rides starting at 1999. So I'm going to call it T for trail rides. They start at 1999. So does that mean that's the highest price, or is that the lowest price? Are there prices that are going to be more than that or less than that? Well, I think they're going to be more than that. So that's going to be greater than. And could I pay $19.99 for a trail ride? Well, that's what it says in the sign. So it could be equal to it, and $19.99. Okay. Okay, the next one, I see this road sign. I've only seen 8 miles per hour before on the sign that's at the dump. So they want you to go slow when you're driving around the dump. So I'll use S for speed. And can I go 8 miles an hour? Yes, you can. But what do they want me to really be doing? It's 8 miles an hour or less. So I'm going to go ahead and say less than and equal to 8. Okay. Now I'm just going to be kind of silly here. That really tells me that I could be going a negative distance or negative speed, and you can't really do that. So I'm going to do something that you do in some other math classes. I'm going to have a limit. I could be stopped, which is 0 miles per hour. So that's a compound inequality. And if you guys just left it at this, I'd be fine. But just to kind of give you a clue that sometimes you have to deal a little bit with reality. Okay. All right. So that's chapter 3, section 1. Hopefully it was pretty straightforward with you. And if you have any questions, please make sure you get a hold of me. All right. Thank you.